We are going to look at a new list, a linked list with a tail node. So just like we had a head node, a head pointer, which was pointing towards the node at the front of the list, the tail points to the tail of the list. That is the last element in the list or the back of the list. Is it clear? Head is pointing to the front of the list and tail is pointing to the back of the list. This is the current situation. Okay, so our intention was to create a structure, a list data structure which can add a node to the back of the list faster. Can I do that here now? Okay, if I want to add a node to the back of the list, what is it I need to do now? So I want to do addBack and let's say 100. What I will do is I am going to create a new node here. I have 100 here and I am going to remove this null from here. I'm going to remove null and that node, in place of null, I'm going to give the address of this newly created node. Now in this case, how did I get this last node? I had to get the last node to change its next value, right? And how did I get that? I got it because I have tail. I have the tail pointer which is pointing to the last node. So I can use the tail pointer to access the last node and change its next value. Clear? Okay. Now I also had to satisfy this extra condition. What is the extra condition? The extra condition was that my tail should be pointing to the last node, right? So if my tail should be pointing to the last node, I have to change. Right now the tail is now pointing to the second last node because we have modified the list. We have added this new node in the back. So I have to now change the tail pointer, which was pointing to the second last node in this modified list, and I should point it to the. Okay, if I do that, I am back to what I started with. My head is pointing to the front of the list and tail is pointing to the back of the list, and I have added a new a new node with the value 100 at the back. Okay, now question is, how many nodes did we visit to do this addBack, right? Now we can say that we visited only. We can write 1 plus 1 if you want. So one node we visited the last node in the original list, and we had to change its next, and then we had to create this new list. We had to create this new node. So there are two nodes which we had to visit. We ask one more question. What about removing the node from the back? So remove back. Now if we have to remove back, we'll have to remove this last node, right? The node with 100 in it. Now if we have to do that, our tail will then have to point to the second last node. But what is the address of the second last node? Where is it? Where is it stored? There's only one place that address is stored. That is the next pointer of the third last node, right? So which means we have to find out the third last node to get the address of the second last node. Now to find out the address of the third last node, I will have to find out the address of the fourth last node, because the address of the third last node is present only in the next point of the fourth last. Arguing along those lines, we see that we have to start traversing from the head node and find out the address of the second last node. Once we find that out, we can assign it to the tail node and also assign the next pointer of the second last node to null. Clear? What I'm saying is we have to get the address of this node, right? And for that we'll have to traverse from the first node towards that node. How much time, how many nodes will we have to visit to do that? We'll have to visit n-1 node, right? Except for the last node. But there is a catch. Is it except for the last node, or should we also visit the last node? We will also have to visit the last node, because until we visit the last node, we don't know whether that is the last node, right? We can't stop at one node and say, okay, I have reached the second last node, because we'll have to go to the last node also and check whether its next pointer is null. In short, I will have to traverse all the nodes to find out which is the second last node. Good. So this implies I will have to traverse n nodes to find out the address of the second last node, and only then I can assign it to the tail pointer. If you want the remove back also to be a constant, 1 or 2, something like that, we'll have to do something else. We'll have to build a different list.